Hello everybody and welcome back to the moshix mainframe channel. This is moshix, and today we're going to be exploring another mainframe operating system. If you remember, I've been offering a MVS system in the cloud that's up 24/7. It's up all the time, and I run it as a production system, back it up. An MVS system that's available to everybody. All you need to do is go to moshix.dino.net, to this website. There's a few explanations and few rules, then you apply, and then you can get a free account on TSO and MVS, and about 110 other people have done that, and they're all using this very actively, and there's always somebody logged on and they use it to explore the mainframe operating system, get to know it better, or maybe they were COBOL programmers in the past and want to do a little bit of COBOL programming. And I've been doing this out of my pocket for the community at large, so people don't have to go and download MVS and the TK4 package and install it and figure out how to run it. All they need is a terminal emulator. I use obviously always Vista TN3270 and connect to my moshix main MVS system in the cloud, and they're log in and they're ready to go. They don't have to maintain it, they don't have to back it up, and don't have to worry about it. So this has been going on for about 6 months, highly successful, I would say, and it's update 8, and soon enough hopefully update 9 will come, and then I'll update to all the amazing new features offered in the TK4 package update 9 of MVS 3.8. But today we're going to be looking at another offering I'm starting this week, and that's VM 370. As you can see here, in the past I had the ability, I was giving people the ability to log in here to get this website and to request a logon for TSO on MVS 3.8, and as of today I'm also making available an account, a free account on VM 370. So you go here, you read the rules, which is don't allocate big data sets, don't run endless loops, and then it tells you where to point your terminal emulator to. Let's say you want to have VM 370, you go to moshix.dino.net at port 3280. That's important, 3280. I will have it also in the description below this video. But you fill out this form, you say you want VM 370, you submit, you agree to the terms, which is to behave, be nice on the system, and within a few days you'll get an account. So what is VM 370? A lot of people in this channel would already know what it is, but some people may not really know about it. It's one of the lesser known mainframe operating systems. So VM stands for Virtual Machine Offering. It started in the 60s. It was at the beginning, it was IBM's research into time-sharing operating system. In the mid-60s, all the rage in computer science was not working in batch anymore, where you would supply a bunch of punch cards and then the data center will process them and give you out the printouts maybe the next day, or if you're lucky, a couple of days later. Some people were researching into making the system available to users in real time. So they would connect with typewriters or teletypewriters, later on with 3270 monitors or other terminals, and they could type commands and the system would answer, and people would several people could be logged in at the same time, and each one of them would have the impression they're working on the computer alone, because the others the other users wouldn't have as big an impact on, or the intention was not for the other users not to have an impact on all the other users. And so that's called time sharing. It was all the rage. Dartmouth University came out with the BASIC system. Remember, BASIC is a programming language, but it also really came out as a time sharing system where several users could log in at the same time and do basic programming and other time sharing systems. So IBM thought they should also have a time sharing system, and they gave some researchers up in Massachusetts the task to look into that, and they came out, they realized that to have time sharing system be effective, you would have hardware protection of memory from the users, so that no user could read the memory of other users intentionally or by mistake. and cause problems. And to do that, you need hardware protection. And to have hardware protection, you need something called virtual memory. Remember, one of the benefits, the main benefit of virtual memory, of course, is memory protection. So address spaces are protected from writing into each other's memory, unless it's you go through the operating system and are privileged to do so. And the other one, of course, is to give each user, each address space, a full view of the full memory range, and therefore you can run faster you can run your programs faster because you don't have to work with overlays, etc., etc. So once that research group was given a mainframe called IBM 360 version 67, model 67, which had something called DAT, dynamic address translation, which is another term for virtual memory. On the Intel x86 CPU, it's called MMU, Memory Management Unit. So once they had this computer, they were able to start implementing a real time sharing system where people were protected one from the other. And so they released that first version as CP67. There was an earlier attempt, as you can see here, called CP40, but that was the memory protection was written in software, and of course that was much slower than if you have the hardware, the processor doing that for you. So they released that CP67. IBM saw that it was a usable time sharing system, and they renamed it into a product which they started making available for their customers, called VM 370, and that's what we're going to be playing today. Later on, they changed it into VMSP, which was one of the few of the SP is always a system product, which means it's a finished product that people have to pay for in the IBM language. And what it had, what VMSP had something that VM 370 didn't have, which is support for newer disk drives, and it had a full screen editor. Those were very important things, and a few other features, but those were the main features. Later on in 1984, when IBM released 31-bit hardware, they updated VM into VMXA, extended architectures, just the same like MVS became MVS XA, and then VM ESA, which had data spaces, and then later on ZVM, and ZVM is very much around today. Still, version 7.1 just came out. It's a 64-bit operating system. Now, very few things have changed from the original implementation, and that's what we need to understand today. So, VM 370 is composed of two systems. One is the hypervisor, the real nucleus that's running on the real hardware. It's called the CP, control program. And then there is the CMS operating system, which is the conversational monitor system, which is what people, when they log in, interact with. That's what gives the interactive capability of VM 370. And so when you're really talking, when you're doing stuff with VM 370 on the terminal, you're really talking to CMS. And underneath CMS there is CP, which is the hypervisor. Now every user gets a virtual machine, and inside the virtual machine there's the CMS running. And today we're going to explore CMS a little bit, and then in one of the future installments of this mini-series we'll look at CP much more in depth. But today we're going to be playing with CMS. So I also want to say something else. This system that I'm running here on the moshix cloud, this 6-pack, is custom tailored by an extremely knowledgeable and very kind gentleman, Professor René Ferland, up in Montreal, in Canada. If I may, I asked for his permission to mention his name, and so since I'm mentioning his name, I'm also going to show him his page, René Ferland, and Montreal. So this is the person. I've had very frequent email exchange with him over the last couple of months, and he put this image together so that it can be run on the moshix mainframe cloud. And Professor René Ferland is instrumental in keeping this running. So in fact he may be even logged in right now, and so I'll show you the very first functionality of VM 370 by doing Q names, query names, and no, he's currently not logged in. So thank you very much, Professor René Ferland, and hope to continue to work with you for a long time. So once you connect to my system by going to moshix.dino.net at port 3280, as you can see here. You're presented with the screen. If you want to log in, you press enter, and then you say as what your user is, assuming you got the user. So of course I'm moshix, and I have my password. And so the moment I put in my password, now I'm logging in. What's really happening is CMS is IPLing. CMS is an operating system, a single user operating system, very similar to in concept like MS-DOS or CPM, meaning that only one user can be logged into this virtual machine at any one time. My virtual machine is called moshix because I'm user moshix. And as soon as I log in, I see that I have a reader, I have a printer, and I have a puncher. So every user sees these three core devices in the mainframe world: a card reader, a card puncher, and a printer. And then I see that I press enter again, and then I see that I see some DASDs. So one of the things that CMS does is it virtualizes real DASDs, real disk drives, into something called mini disks. So if I say query disk, I can now see all the disks that I have. Okay, these are all the disks that are given to me, and they have device numbers. Just like on Hercules, you would have device numbers for real disk images. Every VM370 virtual machine can see something called mini disk, which is virtualized disk. They're not the full size. You can see here the total size that they have. Sometimes they're very small, but they're virtualized drives. And of course, I can also see if I do query dast, Q means query. In CMS, every command can be abbreviated to the shortest unique combination of the characters. So if I say query das, it will still understand it's query dasd, or I can just say q dasd and get the same answer. Every time the screen fills up, if I do that a couple of times and I do it again, you'll see now it says more, which means there is more, but it's on the next screen. How do I scroll to the next screen? Well, in MVS, people used to function key 8 to move to the next page. That's not how it works in VM370 or in CMS. Here you have to do clear. So what I do is I map on my keyboard, I mark PA2, this key here, as shift above this key, which I never use anyway on my keyboard. And so when I do shift and then this apostrophe, it will actually send PA2 to the mainframe. So if I do now PA shift apostrophe, it will send PA2 and it will clear the screen. That's why you should always have PA2 somewhere mapped on your keyboard if you work with VM370. So as we saw, I have virtual disk called mini disks, and then in each one of those there is of course information stored. Some disks are read-write, some others like CMS. This is the disk from where CMS IPLs itself. It's read-only because I don't need to change it, and some other disks with utilities, those are read-only. And then the ones which I control, typically drive A, I call it, this is read-write. So there's a way in CMS to assign a drive letter to a unit. So this is the label of this virtual disk, moshix 91, because it's unit 191, and it's read-write. So let's see what's inside there. Now there's a command which is a full screen command. Well, let me show you first the non-full screen command. List file asterisk asterisk A. If I type asterisk, it means everything or anything on drive A. Why? Because every file in CMS is made out of 3 components. There's the file name, okay, file name, type, and drive. So every file has to be made up of these 3 components. And so if I want to know list file, any file name of any type that's on drive A, I will do like this, and then I get a listing which is non-full screen. It just puts them on the screen. Or if I type fs list, anything on drive A, that's what it will go into full screen mode, and then it shows me some files, and now I can go here, and if I press function key 2, I'll be able to edit that file, or if I press function key 12, I'll be able to view it. Let's do function key 12. Okay, and now I can view it. F3, I can quit and go back here. F3 again, and I quit and go back again to line mode. So let's now say I want to create a file. I will do, so the VM370 on itself doesn't have a full screen editor, but one was supplied with the 6-pack system, which is what we're using here. Okay, VM370 6-pack. There is a distribution put together by a person called Robert O'Hara. Yes, 6-pack, which includes a full screen editor and a full screen file browser, which is the file browser we just saw before. So if I say now EE will be the full screen editor, YouTube text on drive A, it goes into full screen editor. I insert 5 lines. This is a test for VM370 on the YouTube moshix channel. Okay, so now we want to file it, we want to save it, we'll do file, and now written new file as YouTube test A1. So if I want to delete it now, I would say erase YouTube text A, and now it's gone. Erase, of course, is the same command as we had in CPM. There is also another editor, which is the standard editor supplied with VM370. It's called edit YouTube text A. Let's create it again. I will do insert. But see, this is a line editor. It's not a full screen editor, so I would have to type it here: test of edit for video. Okay, so now if I want to change it, I would do and then it puts the line here again for moshix video channel. And now it updated here. So it's different. You can still work with it, and I have for many years. So okay, so we now updated it. So there's 2 editors, of course. EE YouTube. Let's what was it? Text A1. It's much easier to work with a full screen editor. You can do things like you have all the commands. Oops, sorry. Insert 2. Hello. File. Okay. So this is the full screen editor, but as we saw, we also have a full screen file browser. We should now see, yes, here it is. If I say PF12, I'll be able to see it. So we saw erase to delete the file. We saw how to create a file. Copy file is the way that we copy file from one to another. Now the other thing, the interesting thing to do with VM370, of course, is compile programs. So we have a PL1 compiler, type PL1, and the file that you want to compile, it will compile that. We have a COBOL compiler. As you can see here, we have a 4th compiler, which actually don't even have on MVS 3.8, I believe, not in TK4. We also have we're still inside 4th. 4th is an interpreter, so we're inside that right now. How do I get out? Okay, we're back in again. So we have 4th, we have Pascal. Let's look at the Pascal compiler command. So if we want to see, I can search for the Pascal compiler by doing fs list Pascal on any drive. It didn't find anything. List file. Yeah, Pascal compiler and Pascal run. So it's on disk Y2. So if I had the program already written, I could just say pascomp, and that's the Stanford Pascal compiler. So we have lots of compilers. Now, once we've compiled the program, let's look how this looks once we've compiled the program. I have here somewhere a hello in PL1, hello world. Yeah. So let's assume this is called hello PLY, and the PL1 compiler wants the PLI type for files. So I can just say PLI hello. That's it. It already compiled it. So you can see that's of course much easier to work interactively than having to learn JCL to compile a simple program. Most people fail at even getting the JCL right to compile a PL1 program because it's not easy. I mean, you have to learn JCL. It's another language that you have to learn to use the language that you want to use for compilation. So with an interactive system, time-sharing system such as VM 370, you don't have to do that. It's very similar to working with like something like MS-DOS. So let's go see what happened. fs list. You can see here that my hello program has been compiled, and there's a listing created by the PL1 compiler. Let's look at it with PF12. As you can see here, this is the OS 360 F compiler that compiled the program, and it's done. So now we have hello text, which is the object file, and now we have to execute it. How do we do that? We say load hello. It loaded it, and when we loaded by loading it, the loader actually resolves the references in the object file. So in a way, it links it by loading it. And now we can say start. Hello YouTube. Okay. We can also do like this. Hello. Load. Hello. Anytime you want to supply options to a program in VM 370, the convention is to use the left brackets. So if I do load hello, left bracket means this is with this option start. It will load it and start. Okay, so that's how you compile programs. What I mean by that, by the option, is maybe in the Linux world you will do a linkage edit object minus start and so the switch for an option in VM 370 is the left parenthesis. Hello. Oops. Load. Hello. Start. So that's how you do it. Now, there's several other things that you should be aware of if you've never worked with CMS, and that is that you can also you have a help system, very extensive help system. So you type help, you get to the help system. So you can say help query, and you get a help menu for queries, similar to the BAM page. Now, one thing we also need to understand is there's some commands which are strictly CMS commands, and there's some commands which is actually CP commands. When I say query -d, it looks like it's a CMS command, but what's actually happened is that this is actually query -d. It's information we need to get from the hypervisor, and so CMS passes this on to CP, and then you have CP answering. Okay. There's some commands are CMS commands, some other commands are CP commands. If I do query date, query time, it will now, and now if we want to find out if this is CMS or a CP command, help query time. Oh, there's no valid topic for time. Okay, but this is actually a CP command as well. We can also see who is logged in, as we saw before. We can, right now, maint is logged in. Maint is like root in Linux, or like IBM user on ZOS. It's a privileged account. Operator is a privileged account. That's the operator console. And then there are several other users logged in. I'm user moshix logged in on this terminal. I can now send a message to main saying message main, hello you. And we just send him a message. Now if main is logged in, and he is, then he will get this message on the screen. Another thing that we should know is that sometimes people can send us files or even output from their jobs or from their programs to our reader. So if we have something in the reader, you will get a notification, and then to read the whatever is in the reader, you will say read card example A. Okay, so we received something, so let's go look at it. Here it is, card example. When we say read card, it reads from the virtual reader, the card reader. CMS batch facility. Okay, so we see here that we got some messages here from a facility called CMS batch, a batch running utility, which we will not look into today. Alrighty. Let's see here what else we have. Of course, I mentioned before we have a COBOL compiler, and then we also have a command called indicate. Use the indicate command to display at your terminal the use of and contention of major system resources. Okay, so I could say now user indicate load, indicate user. Let's do it again. Okay, so indicate load. Indicate load. It tells me that CPU right now is 2% busy and storage is only 50% full. Or I can say indicate user. Indicate user. It tells me some information about how much I use of the system's resources, or how many of the system resources I use. Now you'll see that I did some other thing, which is I have right now, if I process PF12, it will recall the last command, and if I press it again, the one before. So kind of like in bash, when you move up with the arrow, it gives the previous commands. Same thing here. PF1 is not defined. PF3, as we've seen, goes back, and this is some of the other facilities. If you want to clear the screen, we just do PA2. As I said before, with me it's mapped over the apostrophe key. So that's one of some of the other things, like the help command. I would also today like to show how we can actually do some more fun stuff with it. If I log off as a user and I dial into CP watch. So one of the things you can do is log in the user, which means it starts a virtual machine, or you can attach yourself to an existing virtual machine. So there is a virtual machine called CP watch, which is just a monitor to see what's going on in the operating system, similar to the IMON on the MBS 3.8 TK4 distribution. If I do that, if I dial into it, I can now see what's going on in the system. So I can, if I scroll through it with pressing enter, I can see how busy the system is, which terminals are being used, and which real devices are being used, and we see which users are logged in right now. So since I logged out, yeah, so, and you have the first monitor, the help screen here, and then if I press F12, there's a very nice digital watch here on the screen. Okay, so we can let that run, and I can log in again on another screen session. Motion moshix. Okay, so if I want to print something, I can just say print and then the file name, and it will print it. But of course, for people who log in on this cloud VM 370, they won't be able to get the output when you print, because it's going to go on a file on the disk. And all this environment here, as I said, is running in the Google Cloud on a Linux machine there, so you won't be able to get the output. Now, some other important concepts of CMS is the profile exec. So if I go and see fs list profile exec asterisk, wherever it is, it will tell me it's in A. It's in minidisk A. If I look at it, you'll see that this is profile exec is like the batch file that gets executed every time you log in. Similar to the batch file auto exec that you had when you started MS-DOS in the old days. So there's several things happening. First of all, we have all the linkage edit libraries, so that they're defined there, so that if you load the program that was already compiled, it will be able to resolve the references when loading it. And so you need to indicate what are the names of all those libraries, and here they're labeled. And then we have the definition of the function keys. pf3, pf7, pf8, pf12 is retrieve the last command, and then some other CMS related settings that we need to. This is macafs. This is related to the full screen edit and file screen browser that we're using right now here. So that's important to know. And then a bunch of other query commands that I want to show you. So we saw before, if I write query names or just query, well, I'll do it once like this, and then qn, I'll see who's logged in. If I want to know what is the search path for binaries that I want to execute, then I will just say query search. It will tell me first we'll go to drive A, then D, then G, then E, etc. So if I have, if I copy, let's see where my full screen edit is. List file EE, and let's see wherever it is. It's in U2, and it's in help command. Okay, so if I copy that now, copy file EE, leave it in the same into, I have to say help command U2, and I call it xedit, and I put it in drive A. So now I copied this file here into drive A, and I renamed it into xedit with the same file type. So now if I write xedit, I actually is not able to find it. Why not? List file xedit. Oh, so let's look at it. Type xedit. What is it again? fs list. fs list. Yeah, that's just the help command. So it copied it. So but if this query search gives me the path where commands are being searched for first, then we can also see it's possible for other people to link to the same DASD links. So on my drive 191, I'm the only person linking to it now. So links shows who else is linking to the same drive. It's possible for other people to link to the same drive, but of course only one can write and others can read. That's why when we have this kind of structure, if I show all the disks that I have access to, some are read only, like the CMS disk, because that's attached to every user. So you don't have to give each user a copy of the operating system. They can all read the same operating system as long as they don't change it. So some are read, that's why some are read write, some are read only. Okay, then we can do query file definition. So there's no file definitions in place. We saw already query disk, and that's just query time. Shows the time. So those you should know. And then you should also realize that if you start working with other users on the same system, sometimes they will write something and will send you a message, hey, go read it. They can either punch it to you, to your so I can say, you could send a message saying, message, Bob, please make your disk read only for me, and then Bob is not logged on, and then you would do the same and say, and please send me the password for that mini disk, and then he would answer you back, and then you could say access, and as you drive, I don't know, T, and of course now it's not made available to me, but if user Bob would make it available to me, then I could mount it. So and then he would ask for a password because it's Bob's disk, but you could share information this way, and I guess a lot of people already know about all this. Let me close this stuff. So this is one way to work with it, and that's how people can share information. So now if I want to know, if somebody could also punch something to my reader directly, and then if I do query reader, I could see what files there are in my reader, and I could read those by the file number. So in this case, yes, I have 2 files in my reader waiting to be read. I could say read card 1691, and then I specify 1691 card A, something like that, to store it, and then I can go have a look at it. I'm not going to do it now, but I could also query the printer, anything that's ready to be printed, and I could do the same thing there. So right now, of course, if I print to a certain class, it will go directly to a printer. Some others, it will be held here in the printer. So this kind of shows you how to work with it. I guess one of the most important aspects of VM 370 is that people can work together, and versus in MVS 3.8, the way you would work together is that through the data sets. Here we work through mini disks, so you would share and access each other's mini disk. It's much more conversational, obviously. I just read somebody yesterday posted on a Hercules mailing list, hey, I don't want to run my own MVS or mainframe operating system on my system. It's boring because there's only me there. And is there a place anywhere where I could work with others? Well, yes, VM 370 is perfect for that. You can do program development together. You can share information. You can send each other quick messages. You have all these virtual readers and printers and punchers that you can work with. So there's lots of ways. Now, one thing that is very important is to read the manual. So there's this very famous manual here, the red one I call it. It's an introduction. I'll link to this manual in the description below this video. You kind of have to read through that a little bit to get the feeling for it. GC20 1800-0, that's the manual. There's plenty more, but that would be a good start to start reading about it. So who's read the manual? But this is how you work with it. I give you just in this video a very general overview. In the next few installments we'll look deeper into the possibilities given by CP, the hypervisors. We can see how to run whole other operating systems under CP, such as TK4 and other operating systems. And then in one of the other installments I'll start to look also into other subsystems, such as the networking subsystem of VM 370. But today this is all that I really wanted to show. That's all I really wanted to go through. They're just the very basics. If you want to get an account, again, you will go here, moshix.dyno.net with your browser and read the rules. Stick to the rules. Don't run any endless loops and get CPU time from other users. I'll be very happy to start accepting uses on my VM 370 in the cloud. It's going to be fun to have a VM again in production with plenty of users. We have about 100, maybe 110, 115 users by now on the VM 3.8 system, and it's working out very nicely. And I look forward to what we can see on the VM 370 system. So that's it. I hope you had fun watching this video. If you liked it, please press on the thumbs up button. If you haven't subscribed to the moshix mainframe channel yet, I would urge you to do so now. And I hope you will enjoy playing with VM 370 on the moshix VM 370 system up in the cloud, available 24/7 for free for you as a service to the community. Thank you very much.